Alright, welcome back to my YouTube channel, Master Tutorials, where mathematics literacy begins. Alright, so let's see, elementary calculus. Now, this time around, we are proceeding towards differentiation of the natural exponential function. How to differentiate the natural exponential function. Now, let's see. Rule 1. dx of e to the x, which means when you differentiate the exponential function with respect to x, you still get your e to the x. Then rule 2, if g of x is differentiable, which means that g of x, we can differentiate g of x with respect to x, then dx of e exponent g of x is equal to g prime of x, then we multiply it by what? E to the what? G of x. Which means that you take the derivative of g of x, and when you take the derivative of g of x, which is that, you multiply it by what? The exponential function, which is e to the power of g of x. So we have examples here. Find y dx of the following. A, y equals e exponent x squared. So how best can we find for dy dx? So I have y equals e to the power x squared. So now let's see. How best can we find for y equals e to the power x squared? So now let's see. Y equals e exponent x squared. Now, with this, we can also write it as y equals exponent of x squared. You can write it like this. So when you see this, it's the same thing as that. Don't forget, it's the same thing as that. So now, how do we differentiate? So now, when you see the exponent here, x squared, it is differentiable, so we can differentiate. So we are using root 2. So now, we differentiate, we have dy over dx must be equal to d dx of what? D exponent x squared. Right. So how do we differentiate that? To dy over dx, which is equal to, so we differentiate this x squared, so d dx of x squared, then when we are done, we multiply it by what? Our exponential function here, which is e exponent x squared. So let's differentiate this guy. We get dy over the x, which must be equal to d dx of this x squared to x, then we multiply it again by the exponential function. So we get e exponent x squared. So that's the answer for that. That's simple and very, very trivial. Let's move on to B. So now let's see. Y equals x squared plus 1 multiplying e exponent x to the power what? Negative what? 1. So now we have x term here. So and they are what? Multiplying. So it means that we can apply what? Our product here. So the whole of this is what? U. And the whole of this is what? V. So I apply my product U. This says that what? U dividing over what? X plus v du over x. So my u equals to x squared plus 1. Right? So we differentiate u prime of x, which must be equal to, we get to 2x. This one is 0. Right? Then our v equals to e exponent x to the power negative 1. Let's see, v prime of x should be equal to, we differentiate the exponent. So when we differentiate x to the power negative 1, we get negative 1 times what? Negative 1 drops, so it's multiplied by x, then we subtract 1. Right? Then we multiply it by our what? Exponential function. So I have a prime of x, which must be equal to negative x to the power of negative 2, e exponent x to the power negative 2. Right? So better still, this guy you can write it as what? Negative 1 over x squared. That's the inverse of that, x to the power negative 2. then e exponent of x to the power negative 1. Then this one can also be written as e exponent x to the power negative 1 all divided by what? X squared. So we have it as that. So now we can apply our product rule. So what is u? U is x squared plus 1 times divided the s. We have it as well. E exponent x to the power negative 1 over what? X squared plus our v. Our v is e exponent x to the power negative 1 times our du, which is 2x. So now let's see. When you multiply, you get x squared plus 1 e exponent x to the power negative 1 divided by what? X squared, right? Then we have our plus. You can write it as 2x e exponent x to the power negative 1, which is very simple and very trivial as well. Let's move on to question C. Question C. All right, let's see. Y equals negative x squared e exponent x squared plus 3. Let's see. So now here we have x here. We are differentiating with respect to what? X, right? We have x here, we also have x here. So we can still apply our product rule, which is that u v over what? The x plus v du over what? X. Right. So now this is our u. Then this is our what? V. So our u equals negative x squared. Right? So our u prime must be equal to 2 multiplied by negative 2x. We subtract 1, which is the same thing as negative 2x to the power 1. Right? So we have it as that. Then our v is the same thing as e exponential x squared plus 3. So now how do we differentiate exponential function? We said that you take the power, then you differentiate. So let's differentiate the power. We get to 2x, right? Constant is 0. Then you multiply it by the exponential back again. So we get 2x e exponent x squared plus 3. Then we substitute that into our formula. So what's our formula? U, which is negative x squared times our v prime is 2x e exponent x squared plus 3. Then plus, what is v? V is e exponent x squared plus 3. Then times, what is u prime? U prime is negative 2x. So now we can multiply 2x then negative x squared. We get negative 2x cubed. Then our exponential function. Then here we have minus 2x. Then we have e exponent x squared plus 3. So we have this. We have that. Very, very simple and very, very trivial. Alright. But still, you can do some simple factorization. If you want to factorize, you can factorize 2x out, and also you can factorize what? E to the power of x squared plus 3. Let's see. If you want to factorize negative 2, you can factorize negative 2x out. Then our e exponent x squared plus 3. So now, when you are factorizing, don't forget negative times negative get positive, right? Now the 2 is out, and the negative 2 is out. Now x cubed, we have x here, so it's left with x squared, right? Then here is negative, but don't forget, you have to drop positive. Because negative times positive, you go back to what? Negative. Then our 2 is out, our x2 is out, our e exponent x squared plus 3 is out, so it's left with 1. So, which is very, very simple. So factorization is the reverse of what? Expansion. So when you multiply back, you have to get back to your expression. Negative 2 times 1, you get negative 2. X times x squared, you get x cubed. then that we still get negative 2 times 1, you get negative 2, then our x, then this one to be safe. Right. So let's move on to, let's see question D. Question D. All right, so let's see. We want to find for dy dx. Given e to the x sine 2x plus e to the what? Cos x. So don't forget. Very, very simple. Dy over dx must be equal to. Now, here you can see that they are multiplying, right? So we have to apply what our product will be. Right? They are multiplying, which is the same thing as e to the x, then sine what? 2x, then plus what? E to the cos x. We are multiplying. But this I'm not found for what? My y over the x. It's the same thing as my y. Right. So let's see. For dy dx, don't forget, this is our G, this is our what? V. G and V. What do we say? We say that we have to hold what? G constant. So let's hold G constant. Right. So we get e to the power x, right? Times, we differentiate sine 2x. When you differentiate sine 2x, you get what? Cos 2x. Right? Then you differentiate the expression inside, which means we get what? 2. Right? Then plus, we hold sine 2x constant, then times, we differentiate e to the x. When you differentiate e to the x, you still get your e to the x. Do you understand? So we've applied our product rule here. Right? Then plus, how do we differentiate e to the power cos x? You want to differentiate e to the power cos x, I said differentiate the exponent. The exponent is what? Cos x. When you differentiate cos x, you get what? Minus sine x. So my minus sine x, then multiply by e to the power cos x. So I have this. So let's rearrange. I have dy dx, which must be equal to, now 2 multiplies e to the x, then I have my cos 2x. Then we have plus e to the power x sine 2x. Then our minus e to the power cos x sine x, which is very, very simple. Very, very simple. Very, very simple. Very, very trivial. As well. Alright. So you kindly watch it carefully. It's not difficult at all. I said you have y equals e to the x sine 2x plus e to the cos x. It can be written as that. You can see that we have x turning here, x turning here. So you can multiply, right? And they are multiplying, sorry. They are multiplying. So you can apply our product rule, right? You can apply a product rule. Product rule states that hold e to the x constant. Then you differentiate sine 2x. Don't forget, how do we differentiate trig functions? So you hold e to the x constant, then you differentiate sine 2x with respect to x, plus you hold sine 2x constant, then you differentiate what? E to the what? X. Right. So now we have e to the x, I hold it constant times, when you differentiate sine 2x, you get what? Cos 2x times, you differentiate the expression inside. So you get 2. Then plus, you hold sine 2x constant times, you differentiate e to the x, you still get your e to the x. Then plus, don't forget this guy, because you are differentiating 10 by what? 10. So I'm done differentiating this guy. So I'm left with this guy. So now, if you want to differentiate e to the power cos x, what do you have to do? Differentiate the exponent, then multiply it by what? The exponential. So when I differentiate cos x, I get negative sine x. Then I re-multiply it by e to the power what? Cos x. So now I can write it as 2 multiplies that, so I get 2 e to the x cos what? 2x plus, I get my e to the x sine 2x minus e to the what? Cos x sine what? X, which is very simple and very, very trivial as well. Let's move on to question E. All right, so let's see question E. Tan x then times e to the power cos x minus 2x. Now watch. Tan x is multiplying what? The exponential. X term is here, x term is here, right? So we can apply our product rule. So this one is allowed u, this one is allowed u. Right. So which is u divided over the x plus v u over what? The x. So I said hold u constant. So I have my y over the x, which must be equal to I hold u constant, which is tan x times I differentiate v with respect to x. You want to differentiate exponential? I said differentiate the power or the index. So now we differentiate it with 10 by what? 10. So now if you differentiate cos x, you get what? Minus sine what? X. Then minus, when you differentiate 2x, you get what? 2. Then we multiply it by what? The same exponential cos x minus 2x. Very, very simple. Then we come to plus. V is what? E exponential cos x minus 2x, right? Then times, we differentiate u with respect to x. When differentiate times x is what? Sec squared x, right? So we can rewrite it as y prime equals, now this one can be written as minus sine x minus 2 multiplying it times x, right? Then our e exponential cos x minus 2x, right? Then plus our sec squared x e exponential cos x minus 2x. So we have this. We have this. It is very, very simple and very, very trivial. But still, we can still go further. Y prime must be equal to. Alright, so let's see. So now what's here? Alright, so we can take it again. We can take it again as in. Alright, so let's see. Negative sine x minus 2. Now, these guys are multiplying that. So I can write it as negative sine x, then tan x, e exponent cos x minus 2x. Then I have negative 2. You can also get what? Tan x, e exponent cos x minus 2x. Then I have my plus sec squared x e exponent cos x minus 2x. Don't forget. So don't forget. This one is the same thing as that. You can reduce it because the whole of this is multiplying that, and the whole of this is multiplying that. Right. It is very, very simple and very, very trivial as well. All right. So let's do our last example. Alright, so let's see. Y equals e exponent sine x minus 2 times 3x. So we are finding y prime of x. So I can say that dx of e to the power of sine x minus dx of 2 times 3x. Right? dx of 2 times 3x. Right? So now here, what can we do here? We are differentiating it to 10 by 10. Right? So now let's see. If I want to differentiate an exponential function with respect to x, I said differentiate the exponent, which is sine x. So when you differentiate sine x, the sine x multiplies with the whole of e exponent of sine x. So now let's see. Y prime must be equal to, when I differentiate sine x, we get what? Cos x. So I get cos x. So cos x multiplies with the whole of the exponential sine x. And minus, don't forget, Now here there is no x term available here for the 2. So I can factorize it out. 2 out dx of what? Time 3x. So I have it as that. Right? So I get my y now, which must be equal to cos x dx will sin x minus 2. Then now, if I want to differentiate tan 3x with respect to x, differentiate tan 3x. When you differentiate tan 3x, you get to x squared 3x. Then you differentiate the expression inside, which is what? 3. Right. So I get my y prime equals what? Cos x, leave x equal sin x. Right? And minus 2 times 3, we get to 6, x squared 3x. So we get that. Which is very, very simple and very, very trivial as well. So this is my final answer. So now, you try question G, then question what? H. Question G, then question H. As your assignment or your try. Kindly do go to subscribe to Massa Tutorial. Share, watch, like, and comment. Right. Thank you for watching. Thank you for subscribing. Have a nice day. Bye.